You can also represent a sequence by using function notation. This allows you to plot the sequence using the points n, a sub n, where n is the term number and a sub n is the term. Problem 4. Writing geometric sequences as functions. A geometric sequence has an initial value of 6 and a common ratio of 2. Write a function to represent the sequence. Graph the function. Let's begin with the general form of an explicit formula for a geometric sequence. A sub n equals a sub 1 times r raised to the n minus 1 power. Next, we'll substitute f of x, function notation, for a sub n. Remember, a sub n represents any arbitrary term in the sequence. So we're going to let f of x represent any arbitrary term in the sequence. Then we're going to substitute 6 for a sub 1, our initial value, and 2, our common ratio, for r. This leads us to f of x equals 6 times 2 raised to the x minus 1 power. So the function f of x equals 6 times 2 to the x minus 1 power represents the geometric sequence. We're also asked to graph the function. So we'll determine the first few terms of the sequence using the function. We could create a table of values. We can see here they're just listed in rows and columns. First, we'll find f of 2, so the second term in the sequence, by substituting 2 for x in the function that we've established. 6 times 2 raised to the 2 minus 1 power is 12. So for an x value of 2, we find a y value on the graph of 12. Next, f of 3, the third term, following a similar process, 6 times 2 raised to the 3 minus 1 power is 24, bringing us to the point 3, 24, or an x value of 3 associated with a y value of 24. You can plot that point as well. F of 4, 48. F of 5, 96. And let's not forget our initial value, 1, 6. An x value of 1, a y value of 6. So after we plot the points and connect them with a smooth curve, we arrive at the graph on the right. Your turn. A geometric sequence has an initial value of 2 and a common ratio of 3. Write a function to represent the sequence. Graph the function.